Algebra Honors, Unit 6, Day 8, we're going to add and subtract radicals. So what we're going to do is take a look at what we've got when we get a problem, and if we can simplify our radicals at all, we'll simplify those first. And then we're going to take a look at our radicals. If we have the same index and the same radicand itself, then we can combine those radicals, sort of like combining like terms. For common radicals, we can add or subtract the coefficients, but we would keep that common radical just the way we would keep a variable if we were combining like terms. So let's take a look. I'll try to show you what I mean. All right. If I receive this problem, square root of 18 minus square root of 2, in order to solve that, the first thing I'm going to do is think about simplifying any of the radicals that I can simplify. I can simplify square root of 18, right? So the square root of 18, I simplify, it is the square root of 9 times the square root of 2, which is 3 times the square root of 2. So this is square root of 18. This is also the square root of 18 broken apart, and that is simplified square root of 18. All right, so I have 3 times the square root of 2 minus the square root of 2. So I have 3 of them, and I'm going to subtract 2 of them. So you know that if you had 3x minus x, 3x is minus 1x equals 2x, right? So here's where we're treating our radical like a variable, okay? So I have 3 of these square roots of 2, and I'm going to take 1 square root of 2 away, and that leaves me with just 2 roots of 2. Okay. So here's another example. I have 2 times the square root of 5 plus 4 times the square root of 5. I can't simplify those radicals at all, but I'm already looking at the same radicand, the 5, and the same index. They're both square root, so if I wanted my index, of course, my index would be 2 in there. So they have the same index, okay? So I have 2 of these radicals, 2 roots of 5, and then I'm going to add 4 more roots of 5. So if I had 2 and I added 4 more of them, I now have 6 roots of 5. Okay. So just a review of what makes something a like term here, and which examples here. Oh, I hope you could see all that. I suppose I'll go back and look. What makes something a like term and what makes something not a like term. Square root of 3 and 2 roots of 3. They're both talking about terms of the square root of 3, right? The index is 2, even though it's invisible, and the radicand is 3. So over here, the 4th root of 9, and I have 1 of the 4th root of 9, and I have 8 of the 4th root of 9. And so those are like terms because I have the same radicand, that's the 9, and the same index, the index is 4. When I look here, 2 times the square root of 9 and 3 times the square root of 2, they're not the same. I have the same index, but not the same radicand. I noticed 2 times the square root of 9, it's not simplified, so I'm just going to simplify it right now. That would be 2 times the square root of 9 is 3. That's 6, right? Well, 6 and 3 roots of 2 can't be combined because 6 doesn't have any radical, right? Okay. Square root of 6 and cube root of 6, these are different because of that radical. All right. Okay, so let's continue on and actually start simplifying some of these expressions. So I have 3 roots of 7, and I want to add 5 more roots of 7. So you'll notice I tend to say roots of 7 instead of 3 times the square root of 7. For problems like these, because it makes more sense in my head if I know that I have 3 roots of 7 and then 5 more roots of 7. I have a total of 8 roots of 7. That is 8 times the square root of 7, right? Okay. Over here, I have 5 roots of 3 minus the square root of 12. Well, I don't currently have the same radicand. I do have the same index. So I'm going to rewrite that. That's 5 times the square root of 3 minus, this is the square root of 4 times 3, like that. So this is 5 roots of 3 minus 2 roots of 3. I had 5, I took away 2, I am left with 3 roots of 3. Okay, 11 roots of 5 minus 4 roots of 5. I had 11 of them, I took 4 away, I have 7 roots of 5 left. So again, I am saying that this is 11 minus 4 times the square root of 5. It is 11 minus 4 combined there, times the square root of 5. I have essentially pulled out the square root of 5 with reverse distributive property. Okay, square root of 10 plus 20, square root of 250, excuse me. That I'm going to say is the square root of 10 plus the square root of 25 times 10. 25 times 10 is 250. Alright, so it's square root of 10 plus 5 roots of 10. I have 1 root of 10, and I'm adding 5 more, so my total should be 6 times the square root of 10. And just a quick double check to make sure I'm all the way simplified. 10 only has factors of 1 and 10, or 2 and 5, so no perfect squares inside that 10. Alright, let's take a look at number 5. I have the square root of 7 minus 4 times the square root of 7. So I have 1 of them minus 4 of them. So this is 1 minus 4 roots of 7. So it's negative 3 roots of 7. Number 6, 3 times the square root of 20 minus 2 times the square root of 45. I'm going to see if I can break these up at all. I know 3 times the square root of 20 is the same as 3 times the square root of 4 times 5. Minus 2 times the square root of, I'm going to say that's 9 times 5. So here 3 times 2 is 6 times the square root of 5. Minus, this is 2 times 3, right? 6 times the square root of 5. I just did 2 steps in one, right? I know the square root of 4 is 2, so 3 times 2, and then times the square root of 5. That's how I did that all in one. So 6 roots of 5, take them all away, and we are left with 0. 4 times the square root of 7 minus the square root of 63. I'm going to say that's 4 times the square root of 7 minus the square root of 9 times 7. So here it's 4 times the square root of 7 minus 3 roots of 7. So 4 minus 3 is just going to be 1 times the square root of 7, which we can write as the square root of 7. The square root of 12 minus 7 times the square root of 75. I will say that that is the square root of 4 times 3 minus 7 times. I'm going to say that's the square root of 25 times 3. So now I'm going to simplify. Square root of 4 is 2, so that's 2 times the square root of 3 minus 7 times. I'm going to pull that 5 out, right? This is all being multiplied together, so this will be 7 times 5 times the square root of 3. 2 roots of 3 minus 35 roots of 3. I have negative 33 times the square root of 3. Okay. So maybe on some of these problems you can try them and then come back and see if you get the same answers as me. So you can always pause the video. For a problem like this is different from what we've been doing so far. This has square root of 7 times everything in these parentheses. And so I have to use distributive property. So I'm going to say the square root of 7 times the square root of 7 is just 7. Minus square root of 7 times 2 is going to be 2 roots of 7. Okay, and when I look at that, that first term doesn't have a square root of anything, so I don't have the same index or the same radicand, so I can't combine those. That's it. That's as much as I can do. Okay, over here I had 5 times the square root of 10 minus 3 times the square root of 10 plus 2 roots of 10. So I had 5, I took away 3, and I have 2 roots of 10 plus 2 roots of 10. I just did that first. 2 roots of 10 plus 2 roots of 10 is 4 times the square root of 10. Okay. Here again I have distributive property that I'm going to have to do. Square root of 6 times 7 times the square root of 3. It looks like this. Square root of 6 times 7 times square root of 3, and then plus square root of 6 times 6. Square root of 6 times 6. But now I'm going to rearrange things. Okay, so we like to have our free and clear number on the front, so I'm going to have 7 times the square root of 6 times 3. I can multiply those and keep them under the radical, right? Plus, I'm going to rearrange that so it looks like the way we normally see that sort of a thing. So 7 times the square root of 18, I know I can rearrange that, right? that is actually 7 times the square root of 9 times the square root of 2. Oh, what am I doing? Sorry, forgive me. 7 times the square root of 9 times 2. That was crazy. Crazy talk right there. Right here in front of you. Okay, plus 6 times the square root of 6. So 7 times 3, right? I can pull out that square root of 9 is 3. So 7 times 3 is 21. So I have 21 times the square root of 2 plus 6 times the square root of 6. And I don't know of another way to simplify that, right? Because I have the same index, but I do not have the same radicand. Okay, over here I have 4 times the square root of 3y plus 7 times the square root of 3 minus the square root of 3y. Remember, the index has to be the same and the radicand has to be exactly the same. So the only like terms that I have are these guys right here. This negative is glued to the term that follows it. Okay, so I have 4 of these minus 1 of them. So I have 4 roots of 3y minus 1 root of 3y is 3 times the square root of 3y. And then the other thing that I have is plus 7 times the square root of 3. These cannot be combined. They're pretty close, but they are not exactly the same. So square root of 3 is not the same as square root of 3y. So that's it. I would end my problem there. Okay. 2 times the square root of 5 plus 3 times the square root of 3. What happens if they're not like terms? These are not like terms because I have a different radicand. I can't do anything. 2 times the square root of 5 plus 3 times the square root of 3. That's it. Square root of 7 plus cube root of 7. Can't simplify that at all. So I just leave it like that. Stays the same. Okay. Find the area and perimeter of a rectangle with a length of square root of 45 and a width of square root of 5 plus 4. So realize that this width, that amount has to be in parentheses. The width is all of that. So if this is my rectangle, I'm finding the area and perimeter. So I know area equals length times width. So I'm just going to say the length is 45 and the width is square root of 5 plus 4. So I know area equals square root of 45 times square root of 5 plus 4. Okay, I can simplify that square root of 45 first if I want to, and I think I might. I think I'm actually going to go ahead and say that that is the square root of 9 times 5. This is all, oops, keep that all under the house. Keep this square root of 5 times 4. So I know that that is 3 times the square root of 5, right? Times the square root of 5 plus 4. I'm doing that because now when I use distributive property, it's just going to be, it's more numbers that I'm willing to work with. 3 times the square root of 5 times the square root of 5 looks like this. 3 roots of 5 times the square root of 5, right? 3 times the square root of 5 times the square root of 5. Plus 3 times 4 times the square root of 5. And I wrote it in that order because I know I'm going to multiply the 3 and the 4. Square root of 5 times square root of 5 is just 5. So this is really 15, right? Square root of 5 times square root of 5 is really square root of 25, which is 5 again. So I'm undoing my square root sign there. So 3 times 5 is 15 plus 3 times 4 is 12 times the square root of 5. I just want a sidebar over here. I'm going to do this again. Okay, 3 times the square root of 5 times the square root of 5. I just want you to really believe me. This is really 3 times the square root of 25, right? 5 times 5 is 25. And that really is 3 times 5, which is 15. I have taken the square root. I was able to do that operation. I took the square root, so there is no longer a square root sign here at all. Okay, so if this is my answer, this is the area, I can't simplify it at all now, right?